This video is about equivalent equations. All right, here's what equivalent equations are. Two equations are equivalent if they have the same solutions. Okay? They're equivalent if they have the same solutions. All right, so let's look at this little example here. Which of the following equations is equivalent to the equation x plus 1 equals 6? All right, so think about this equation here, x plus 1 equals 6. All right, what would the solution be? Right, and if you remember, the solution is the number that when we replace x with it, it's going to make that statement true. Right? And so it should be pretty obvious that the solution to this equation is x equals 5. Right? Why is that? Because if I were to place x with 5, well, 5 plus 1 equals 6, that's a true statement. Okay? So the question is, which one of these is equivalent to this x plus 1 equals 6? In other words, which one of these has the same solution as this? Which one of these has the same solution of 5? Pause for a second and think. See if you can figure out which one's equivalent. All right, welcome back. The answer should be this equation. Right? Why is that true? Right? Because the solution to this equation would be 5. Right? Because if I were to place x with 5, 2 times 5 is 10. Right? This is true. Right? If I put 5 here, 5 plus 2 is 7. Right? That doesn't work. Right? The solution to this would be 1. Right? 1 plus 2 is 3. Right? The solution to this one would be 1. Right? So these two, x plus 1 equals 6 and 2x equals 10, even though they don't look alike, right? These two equations don't look alike. Even though they don't look alike, these equations are actually equivalent. Why? Well, because they have the same solution. The solution to this equation is 5. The solution to this equation is also 5. Right? They're equivalent because they have the same solution. All right, so in the rest of this video, what we're going to do is we're going to create equivalent equations. Here's how we can do that. You can create an equivalent equation by performing an arithmetic operation to both sides of the equation. Right? You may have heard a teacher say it this way. Right? If you do an operation to one side of an equation, if you want the other side of the equation to still be equal, you need to perform that same operation to the other side. Or the short way of saying that is you need to do the same thing to both sides of the equation. All right, let me show you an example. All right, so we have this equation here. 3x plus 6 equals 18. Let me write that here. 3x plus 6 equals 18. Right, and I'm going to tell you right off the bat, the solution is 4. Right, and you can check if you really want. Right, but it makes sense. 3 times 4 is 12. 12 plus 6 equals 18. Right, so the solution is 4. All right, what we want to do is we want to create an equivalent equation by subtracting 5 from both sides of the equation. Then we're going to check to see if our new equation is equivalent to our original equation. Okay, so let's subtract 5 from both sides of the equation. So I have 3x plus 6, and I'm going to subtract 5 from the left. Right, well, in order to make an equivalent equation, we need to do the same thing on the left that we do on the right. So on the right-hand side, I also need to subtract 5. What does that give us? That gives me 3x plus 1 on the left, and that gives me 13 on the right. Okay, so right here, this is our equivalent equation. What we're saying is that this equation is equivalent to this equation. Right? Why is that true? Right? Well, I'm going to check to make sure. Okay? All right, so if these two equations are equivalent, that means they have to have the same solution. We already know that this equation has a solution of 4. Let's check to see if this one still has a solution of 4. Right? So let's check to see if 4 makes this true. Let's replace x with 4. Right, so that gives me 12 plus 1 equals 13, and which is 13 equals 13, which is true. Right, so yes, this has a solution of 4. Both of these have solutions of 4, so they are equivalent. Let's look at another one. This time we have the equation negative 5x plus 3 equals 18. And again, I'm going to tell you the solution is negative 3. Let's create an equivalent equation by adding 7x to both sides of the equation. All right, so let's do that. We have negative 5x plus 3, and let's add 7x to this side. Right? But if I want to create an equivalent equation, I need to add the same thing to the right-hand side. All right, so let's see what we get. All right, actually, you do this. Pause the video and simplify this and see what you get. Welcome back. Well, on the left, we can rearrange our terms. So this would be negative 5x plus 7x plus 3. And I'm also going to go ahead and rearrange the right-hand side. Let's put 7x plus 18. And if I simplify the left-hand side, this would become negative 5x plus 7x, that's 2x. 2x plus 3 equals 7x plus 18. All right, and here, this is our equivalent statement. Again, what we're saying is that this statement is equivalent to this statement. Why is that true? Because they both should have a solution of negative 3. Right? The original equation, let's check that one. Negative 5 times negative 3, this is 15, plus 3 is 18. Right? I'm going to have you, again, pause and check to see if negative 3 is a solution of this equation. All right, welcome back. So I'm going to show the work. Let's check. Right, 2x plus 3 equals 7x plus 18. So we have 2 times, let's check if negative 3 is our solution. Let's plug in negative 3. So that gives me negative 6 plus 3 equals negative 21 plus 18. Oops. And that gives me negative 3 equals negative 3, which is true. Okay, so yes, negative 3 is a solution to this equation, right? And it's also the solution to this one. So these two statements are equivalent. All right, again, I'm starting out with an equation here. 2x is equal to 3x minus 6. Right, I'm telling you that the solution to this statement is 6. Right, let's do a quick check, make sure I'm right. Right, if x were 6, 2 times 6 would be 12. Right, this would be 3 times 6 is 18. 18 minus 6 is also 12. So yes, 6 is the solution to this. Okay, all right, here's what we want to do. We want to create an equivalent equation by multiplying both sides of the equation by 2. All right, I want you to do that. Let's see if you can multiply both sides of the equation by 2 and get an equivalent equation. All right, welcome back. So let's multiply both sides by 2. If I multiplied the left side by 2, that would be 2 times 2x. And then if I multiplied the right side by 2, that would be 2 times 3x minus 6. Let's see what we get. We get 4x on the left. On the right, we have 2 times 3x, let's distribute, plus 2 times negative 6. That gives me 4x is equal to 6x minus 12. All right, and I'm claiming that this is equivalent to this. Why is that true again? They're equivalent because they should have the same solution. All right, let's do a quick check. All right, our new equation is this, 4x equals 6x minus 12. Let's check to see if 6 is a solution. All right, so let's see. Let's plug in 6 and see if this is true. 4 times 6 needs to be equal to 6 times 6 minus 12. All right, I have 24 on the left, and then I have 36 minus 12, which is also 24, which is true. All right, so that proves that 6 is a solution of our new equation. All right, so once again, our conclusion is that these two statements are equivalent because they both have the same solution. All right, last one. We have our equation 40 minus 12x equals negative 4x. And I'm going to tell you that the solution is 5. Right? You can check if you want. If I were to replace x with 5 here, negative 4 times 5 would be negative 20. On this side, 40 minus 12 times 5, well, this would be negative 60. So 40 minus 60 is negative 20. Okay. So I said that really fast, but just believe me, 5 is the solution to this equation. Here's what we really want to do. We want to create an equivalent equation by dividing both sides by negative 4. And then we're going to check to see if our new equation is equivalent. All right, one last time, pause and divide both sides by negative 4 in order to create an equivalent equation. All right, let's see what you got. If I divide this side by negative 4, I also have to divide the other side by negative 4. What does that give me? Well, let's divide on the left. On the left, I need to divide both the terms by negative 4. So 40 divided by negative 4 is negative 10. And then negative 12x divided by negative 4, that's going to be positive 3x. And then on the right, negative 4x divided by negative 4, well, that's going to be just 1x, or x. Right? And so here is my equivalent equation. And I'm saying that this equation is equivalent to what we started with. Negative 10 plus 3x equals x. That's equivalent to this equation. 40 minus 12x equals negative 4x. All right, let me prove it to you. All right, let me do a quick check. Right, and if those two equations are equivalent, they should both have a solution of 5. Let me check this last equation. Negative 10 plus 3x equals x. Let's see if that is true, if x is 5. Well, let's see. Negative 10 plus 3 times my x value of 5. Is that equal to 5? All right, so this is going to be negative 10 plus 15. Is that equal to 5? Yes, 5 is equal to 5. That's true. Right? What does that, again, what does that mean? That means 5 was a solution of this, right? Which means these two have the same solution, which means these two equations are equivalent.